Lesson 5-6, Graphing Inequalities in Two Variables. Our essential question today is how do you graph a linear inequality on a coordinate plane? Our first vocab word is boundary line. What we will see today is two different kinds of boundary lines. Some boundary lines are dashed and other boundary lines are solid. We will see two different kinds of half planes as well, and those go right along with the type of boundary line. An open half plane is when you have your coordinate plane and you have your line graphed and it's a dashed line. So a dashed line does not include the boundary line. Your dashed line could be horizontal or vertical. It could have a positive slope or a negative slope. So any kind of line that we've already learned how to graph, any kind of line could be used. But the open half plane has a dashed line, so it doesn't include points that are on that boundary line, and then it is shaded on one side. It might be shaded below the boundary line, or it might be shaded above the boundary line. So we call these open half planes because you're not including the boundary line, and then a half plane is half of the coordinate plane. Half of the coordinate plane. Our next vocab word is a closed half plane. It's very similar. So I have my coordinate plane, and we are going to be shading half of it again because it's a half plane. The difference on these is that your line is a solid line. So you are including in your solution region, you are including the points that are on that boundary line. So it may be shaded below, like this one, or above, like this one. So all of these half planes, when you're solving and when you're graphing and solving a linear inequality on a coordinate plane, the solution set is the shaded region, the shaded region. So in all of these graphs, any points that are in the shaded region, so any of these points in the shaded region are solutions to the inequality. And with the open half plane, you can't include points that are on the boundary line, but with the closed half plane, you could include points that are on your boundary line, like these. Okay? So we are going to be graphing inequalities, and we're going to focus on the inequality symbol to figure out what kind of a half plane it is and what kind of boundary line. Okay, so if we change the equal sign to an inequality symbol, how does it affect our graph? How does it affect our graph? So typically when we're graphing, we graph slope-intercept form, y equals mx plus b. So now what's going to happen is that equal sign is going to be a less than or equal to, greater than, or greater than or equal to now. So if y is less than mx plus b, less than or equal to mx plus b, and so on, I'm going to give you some shortcuts for drawing your graph. Okay, so the open half planes, those are going to happen when we have less than symbols. So we're going to have a dashed line for our less than and a dashed line for our greater than symbols. And that should make sense because there's not an equal underneath the symbol. And when we were graphing on a number line, we would say that we would have an open circle on our number line for a less than or greater than. We'd have an open circle on our rays. Now we're having a dashed line on our graphs. So we're not including the points on the line. The solid lines then, those go with the symbols that have the equal underneath. So less than or equal to and greater than or equal to. Those are both going to be solid lines. Then the shading piece comes into play. The less than symbols both need to be shaded below. Shaded below. Because below the line would be less than the line. So less than and less than or equal to, both of them you shade below your line. It will make sense when you see, it will make more sense when you see the next couple of examples. And then the greater than symbols, we're going to shade above the line. Okay, so these shortcuts work when your inequality is written in slope-intercept form. So it has to be written in slope-intercept form to use these shortcuts about where to do your shading. The solid and dashed lines, those just depend on if there's a line underneath the less than or greater than. The line underneath, the equal line underneath, makes it solid. But the shading piece, it's very important for the shading piece that your inequality be in slope-intercept form. Okay, so my first example here, this is in slope-intercept form right from the start. So remember, with slope-intercept form, you graph the y-intercept first, and then you use the slope to get the rest of your line. So I graph the y-intercept first. In this example, it is positive 4. So on the y-axis, that would be positive 4. Then I make my slope a fraction. Negative 3 over 1 means I go down 3 over 1 to the right, like this. I'm going to keep going with my graph because, remember, we're talking about a half plane here, shading a half plane. So I want to cover the entire grid that has been given to me. Now I'm going to look at my symbol. My symbol is greater than. A greater than symbol without a line underneath it means that I have a dashed line. So I need to dash my boundary line. And then greater than means that you shade above the line. So if I look at where this intercept is, I look at my intercept as my starting point, and then I want to shade above it. Above my intercept of 4 would be here, 5, 6, 7, and so on. So this is the side of the line that I'm going to shade. So any points in this region, and remember it is going to keep on going forever, so any points in this region are solutions to my inequality. Now, before we move on, I'm going to show you how to use a test point to check your shading. So I'm going to pick a point that is in my shaded region, and I'm going to show you that it works. So this point right here is 3, 3. I'm going to show you that if I plug in 3 for x and 3 for y, my inequality is true. So I'm substituting 3 for x and 3 for y, and I'm just simplifying. Negative 3 times 3 is negative 9 plus 4. Negative 9 plus 4 is negative 5. 3 is greater than negative 5 is true. So that means that I have shaded the correct side of my line. If it was false, that would tell me I had shaded the wrong side. So every point in my shaded region, every point that's a solution is going to be true when you substitute it into your inequality. And remember, you substitute x and then y. Mine I selected was 3, 3, so there was no way I was going to make a mistake. Both of them were replaced with 3's. Now, I need to name 2 points that are solutions. Well, I've already got one. It's 3, 3. So I can pick one more. Maybe I pick this point right here, 2, 5. So those are my 2 points that I've selected for the last part, where it said name 2 points that are solutions. You just need to name 2 that are in your shaded region. Okay, my second example is going to require a little bit of work because it's not in slope-intercept form. So I'm going to rewrite it to get it into slope-intercept. To do that, the x is on the wrong side, so I need to subtract it. Then I bring down my 3y. It's less than or equal to negative 2x minus 6. Make sure that you write this in slope-intercept order. And then divide everything by 3 so that my final answer is y is less than or equal to negative 2/3 x minus 2. I'm keeping this slope of fraction, because having the slope of fraction makes it easier to graph. Now I can graph. I start at -2, and my slope says to go down 2/3, so down 2/3 to the right. I keep going to reverse this the other direction. This one is a solid line because it's less than or equal to. So my symbol right here tells me to make my line solid for my boundary. And it's a less than symbol, so that means that I'm shading below my line. So again, go to your y-intercept -2 and then go down below it. So below it is here in this region. And this one can go right up to the boundary line. Then we're going to use a test point in the shaded region. I can pick any point that I want in the shaded region to plug in. I'm going to go with some positive numbers. So 1, -4. So that I've got at least one positive number. So 1, -4, remember it's x and then y. So if I plug it in my inequality says 2x plus 3y is less than or equal to -6. So my x is 1, and my y is -4, and I need to check to see if this is true. So 2 times 1 is 2, 3 times -4 is -12. 2 minus 12 would be -10. That is less than or equal to -6. True. So I've shaded the correct side. Now I can pick another point that's a solution. So maybe -3, -3. So now I've got 2 points identified in my solution set. Okay, one more that needs a little bit of work. And I'm going to, before I solve this one, just put the 1 in front of the y. So I need to subtract 3x on both sides. -1y is less than -3x plus 2 then. And divide everything by -1, which is going to flip my symbol. So y is greater than 3x minus 2. So I start my graph at -2. I go up 3/1. And then I make sure I'm looking at my new symbol, it's greater than. So this would be a dashed line, because it doesn't have a line underneath the symbol. And then greater than is shaded above. So above the y-intercept, so higher than -2 would be up here. So I shade this side, and then I need to pick 2 points that are in my solution set. 2 points. So I'm going to pick 1, 4. I'm going to do my test point, 1, 4. So where the y is, I put a 4, and where the x is, I put a 1. 3 times 1 is 3, minus 2 is 1. So 4 is greater than 1. True. True. And then another point in my shaded region, maybe -2, 2, right here. Okay, our last example. Write an inequality and graph using the intercepts. Students get a pizza party if they sell at least $1,000 worth of pies and cheesecakes. So at least, remember at least means greater than or equal to, because they have to sell enough to get $1,000 or more. So at the very least 1,000, so not less than 1,000, greater than or equal to. So they get a pizza party if they sell at least $1,000 worth of pies and cheesecakes. Each pie is $10, and each cheesecake is $15. So I'm going to say X represents pies, Y represents cheesecakes here. You can use whatever variables you want. I just find it easier to use x and y because when we're graphing with the x and y axis, it's a little easier to work with. So if each pie is $10, that means 10 times each pie. I almost changed my letter on you. So 10x plus cheesecakes are 15, so 15y. Okay, now notice in the directions, it says graph using the intercepts, because the easiest way to graph this one is going to be by finding the two intercepts. Finding the two intercepts.
Trayton Burrell and Dylan Moreno, please report to the office. Trayton Burrell and Dylan Moreno, report to the office. Thank you.
Okay, so to find the first intercept, I put 0 in for x. So 10 times 0 is 0. So 15y is greater than or equal to 1,000. So this is if we're not selling any pies. It's just all about the cheesecakes. So if I divide this, I get y is greater than or equal to 66.6 repeating. So there's one of my intercepts. To find the other one, I put in the 0 for y instead. So now we're talking about selling only pies. 15 times 0 is 0. So if I divide 1,000 by 10, x is greater than or equal to 100. Okay, so now we're ready to draw our graph. I'm going to slide this a little bit. Okay, so on the x-axis I have pies. And we found my x-intercept to be 100. So I'm going to go by tens. Okay, so that would be my 100. So there's my intercept. Right there, I'd have to sell 100. Then in the other direction, I'm still going to go by tens for the cheesecakes. Okay, and for cheesecakes, 66.6. It's about right here. And our symbol that we used was greater than or equal to. So I can connect these. And then greater than or equal to actually means that I'm going to shade over here. So this is the region that our solutions would lie in. So in order to find two combinations that are solutions, I need 2 points that are clearly in my solution set so that I'm not guessing. So I'm going to pick a point up here. Like this looks to me like 70 pies and 50 cheesecakes. Okay, and then if I pick another point that looks clearly in my solution set, maybe this one. So this is 30 pies
come to the office,
and 70 cheesecakes. Okay, so you can choose whatever two order pairs you want. Just make sure that they're clearly above the line. And that's it. You should be able to write a summary now. Make sure that you use complete sentences and answer our essential question.